Industrial enterprises routinely authorize multi-million-dollar capital expenditures for reactive data cleansing projects, only to watch their operations continue grinding to a halt. The results follow a frustrating paradox. Within 6 months of a successful database cleanup, the data rots right back to its original, degraded state. On the facility floor, this decay is highly visible. Duplicate parts are out at the dock, work orders are issued missing details, and schedules slip by weeks. This timeline illustrates the core misunderstanding driving the failure, assuming data decay is a static software glitch. Treating that downward curve as a purely technological problem guarantees the organization will repeat this loop infinitely. Poor data physically alters the daily survival behavior of the maintenance technicians and planners working on the floor. We will trace the mechanical pathway from a single broken data point all the way to a full-scale operational workaround. Resolving maintenance failures requires abandoning the IT perspective entirely. We have to understand data as a physical driver of human behavior. To find the root of the problem, we shift focus down to the micro-starting point, how information practically flows through an EAM system. Data does not degrade uniformly across a facility. Look at this model of an EAM flow. The information fractures at specific, predictable stress points. These joints, as had hierarchy, the bill of materials, work orders, and modifications, function as the critical handoffs required for maintenance execution. When the system fails, it often starts with a leak specifically here at the parts and bill of materials joints. When a maintenance planner opens a file and encounters a missing or inaccurate bill of materials, they hit an immediate operational roadblock. Without an accurate parts list, the planner pauses the digital workflow, leaves their desk, and walks the floor to manually verify physical components. That single fracture cascades, because the planner loses hours to manual verification, resulting downstream work orders are generated in a rush, missing critical technical instructions. The entire theoretical maintenance process halts. The execution teams arrive at the asset, but they lack the required technical parameters to actually do the job. These structural breaks manifest as physical roadblocks that force the operation to stop relying on the software to get work done. This chart tracks the immediate psychological consequence of encountering broken data points, the erosion of trust. As data quality drops, the tethers connecting key personnel to the centralized system snap one by one. Planners, supervisors, and reliability engineers are rational actors. They will quickly abandon a system that outputs false parts lists. This loss of trust isolates these specific roles, severing their daily decision-making from the formal data environment completely. This flow diagram maps that survival instinct. Once isolated, rational professionals create a translation layer between the broken system and their daily tasks. We call these behavioral workarounds, the manual, shadow processes created out of necessity to bypass the untrusted software. For planners, this means abandoning the EAM to build offline schedules. For supervisors, hoarding parts in hidden off-book stashes. For technicians, relying on guesswork rather than documented repair histories. These unaligned survival tactics cause massive internal friction, especially between supervisors who are pushing for speed and planners who desperately need accuracy. Because these actions happen off-book, accurate ground truth is never fed back into the main system. This feedback loop of hidden information is the exact mechanism that accelerates the initial data decay. Inaccurate server data actively incentivizes shadow systems and survival behaviors that eventually replace formal operational processes. The daily proliferation of these shadow systems connects directly to the massive financial bleed experienced by the enterprise. We must differentiate between localized costs executives track and compounding costs the plant floor actually suffers. This iceberg model separates the two. Above the waterline, we see visible costs, expedited shipping, and contractor fees. These metrics are the visible symptoms triggering panic in accounting. But looking beneath the waterline reveals a massive submerged layer: wasted wrench time, shadow inventory, and deferred maintenance. These submerged categories represent the direct, compounding financial toll of the behavioral workarounds we tracked earlier. Wasted wrench time scales exponentially as technicians spend hours hunting for hoarded parts instead of actually executing repairs. It is futile for an organization to try reducing visible contractor fees while completely ignoring the foundational friction happening beneath the surface. Over time, the hidden drag of undocumented shadow inventory eclipses the operating budget. Traditional accounting fails to measure true operational bloat because it ignores the hidden costs generated by the trust gap. The mechanical model is now clear. Poor data creates a trust gap. That gap forces behavioral workarounds, which generate massive hidden costs. Returning to our timeline, why does standard database cleanup inevitably fail? IT teams only scrub digital records without addressing the lack of operational structure. To stop the decay, the organization must install a strict ownership and governance architecture. Practically, this means establishing clear rules on who owns the bill of materials, strict procedures for work order modification, and single points of accountability. Restoring behavioral trust through this systemic governance is an absolute prerequisite to touching the data itself. Until human behavior on the floor is supported by a trusted framework, shadow systems will always overwrite clean data. The rule is simple: structure first, cleanup second. First, establish the governance, rebuild trust with the floor teams, and only then execute the final data cleanup.